So last time we showed that you have a group homomorphism, then the order of the image of G was always smaller than the order of G. And now we're going to show that it's smaller in a particular way. It actually divides the order of G. Well, before, what we had done was we wrote K for the order of G. And we looked at the order of this element here.
Maybe we want to name it as something.
Okay. What should we name it?
I think it's use. It's that the order of the phi of G is D and the order of G is N in the hint. So
okay,
maybe we want to use
this one's going to be called D.
And
this one's still called K.
Sure.
Okay. And I want to show this thing divides this other thing. So I guess I should do division algorithm again. That seems like a good tool for figuring out whether things divide other things when they're integers. So I already know that one of them is bigger than the other, which was the big one.
K is
the big one. So I should divide K by D.
Yeah.
It should be D times some quotient Q plus some remainder. And the remainder should be at least 0 and smaller than D. Okay, let's see what happens then when we use this.
Yes.
Okay, so G
So we know that G to the K is E, so maybe we want to put that in phi.
I want to take this and hit both sides with phi.
Yes.
Okay, so I'm going to get that phi of G to the K is phi of E. Well, that's just E. But this is more interesting. I can rewrite it in a couple of ways. So first of all, let's just rewrite K. But secondly, we can also use the homomorphism property. Now we should be able to do some exponent tricks here. So multiplying, having a sum, so phi of G to the D, all to the Q, times phi of G to the R. Am I still on the screen? Oh, plenty of room. Okay.
So
we must know some stuff.
We know that the order of phi of G is D. So phi of G to the D should be E.
This is all E.
Yeah.
Okay. This is equal to E to the D to the Q
Just E.
E of G
I think
to
it's
the R.
I think it's just E. Not
Oh,
E to
you're
the D.
right. There's no D. We already used up the D.
Yeah.
Yeah. Okay. But it all goes away anyway. This is just phi of G to the R. And now if we follow through this like horrible board work, this huge chain of equalities, we get back to this E.
Yeah.
So I have E equals phi of G to the R. And have I learned something? Well, D was supposed to be the order of phi of G. R is strictly smaller and has the property that the rth power of phi to the G is the identity. Well, that can only be the case if R is 0.
Yeah.
Otherwise, this wouldn't have been the order of the element. So, r equals 0 is not what we wanted.
Which means D should divide K.
Yeah, when I did this division algorithm, there was no remainder. So they must have divided like that.